Hello, everyone. I don't know if you guys can hear me correctly, but here it's me, Jackie, with my friend, my good old friend Jilin from Berkeley. We met at Berkeley and we started to do this series for us reading some AI related paper and reports, mostly in English, from the source that I found, like the reports from Google and Cisco, the paper from OpenAI. We're just gonna read it together and we're gonna discuss it, and I'll try to ask some questions um, from Jilin right away. It's like a recording of us studying materials about the industry and the papers. So like a brief introduction of myself is that I'm currently a software engineer at Citibank. I graduated from University of Illinois, and my master's degree was in statistics at UC Berkeley. And we studied a lot of machine learning back then. So we have like this at least I have this general understanding of AI and machine learning. And like the reason why I'm trying to read all this is because I want to quit my current job and find my new career in the AI infrastructure, AI startup industry. So I'm trying to gain as much as much of knowledge as I can in a short period of time, and it's a good way of studying and do something together. So, Jillian, can you like introduce yourself?
Yeah, Jackie and I met at Berkeley, and after I graduate, I work as a software engineer for two companies. The first one is Hitachi. I work as a front-end developer, and the second one I work for TikTok for a short amount of time. I work as a kind of like a full stack software engineer. Although my background is statistics, but I learned software engineering by myself. Um, I think the good thing is that I got my hands dirty on both area. So I think nowadays, um, some people are only focused on AI, some people are only focused on machine learning, and some people are only focused on software engineering part. So I think having both skills uh, is still very rare. So I think it's a good thing to have like both skills. But I think the purpose of our we're doing this kind of things that we kind of want to push each other because usually studying alone is kind of boring. Um, at least we got some momentum to learn some AI knowledge together. Yeah.
Yeah, why don't you talk about your like current PhD program?
Yeah, I'm a first year PhD student at Hong Kong University, like City University of Hong Kong. I currently I'm not really enjoying it very much because yeah, because I don't know what to do. And most of the time, like during the week, I just spend I spend most of my time reading novels, like classical novels. At least I'm having fun. So uh I used to in the past years I learned a lot about AI because I have to. My professor gave me some assignments about agents, multi-agents, and what else? Reasoning part. So I think I'm kind of familiar with the current trends. So
Okay.
yeah, I do have some insights, I think. Although I'm not like a super expert, but I think I have some like basic understanding pretty well.
Yeah, I agree with you. Okay, I trust you. I believe in you. You have like better understanding of the technical part than me. Um, as I said, I want to find a opportunity in the AI business as a account executive. So a lot of my perspective will come from business and like sales and stuff. I don't want to do software engineering anymore. And thus it's also it's a like a so we're gonna post it on social medias like Bilibili and YouTube, and hopefully they will it will opens up some window for us to find opportunities in this industry and see how us will grow as like whatever business development professionals and machine learning engineers. Okay, let's get started. So, what will we do is that we're gonna read a paragraph. I'm gonna read a paragraph, and then you gonna read a paragraph. Then we'll like briefly talk about what's going on in this too. Can we do that?
Okay.
Like, yeah.
Okay.
Okay, so the emergence of agentic AI. We're entering the Internet of Agents era. Today, our workforces are entirely human. Tomorrow, they will expand exponentially to include a variety of non-human AI workers, including apps, agents, robots, and even humanoids. Agentic AI introduces a world where connected AI agents and people will work together to orchestrate all manner of complex workflows. This will result in massive gains in productivity and capacity, with considerable shared benefits for organizations, workers, and society alike.
Okay. Do you have any questions about this paragraph?
Oh, I just have like one random thought of this Internet of Agents era. So I remember I've read an article about um Bitcoin and like what's that? A blockchain
Mm-hmm.
technologies. It's basically saying that this technology will be very popular after 10 years because the Internet of Agent era is coming up and AI will work with another AI. So how will them to do transaction amount APIs and AI agents? It will be blockchain and using those cryptocurrency, right?
Yeah.
Because um, like if they transact the real money, it would be too small of a transaction that a bank would barely take. But if that's using blockchain or cryptocurrency, then that transaction will be seamlessly. I don't have any domain knowledge about crypto and blockchain, but I think that's a like interesting point to point it out. That
Okay, but
reminds me.
I think I have a question. Do you know what agent is? Like, do you have a clear understanding about it? Like, what is an agent?
An agent,
Yeah.
like from my understanding is that um like you ask your AI agent to do specific tasks for you, and this agent have this access and authorization to like a lot of apps and a lot of APIs on your server, and that they can perform some tasks as they are human beings. That's what I understand. Please correct me if I'm wrong.
I read some articles about like a lot of people got confused with agent and the workflow. I think what you described is more like a workflow. So agent
Mhm.
is like you can think about agent like a game AI, for example, the chess AI, where like the AlphaGo, it has like it is independent. It can takes input and think about it and do an action. And if a new input is given to the like basically it's like some robot in real world. It can react to different kinds of scenarios and then respond based on the observation and then give feedback to the environment. But workflow is like a one-to-one. It's like think about it like a river. You give this thing a command, it will do things. For example, you can talk to your computer, say, call this API for me, right? But it's same as you click the button, or you just yeah, similar to click a button. It's just instead you use your like mouth to speak it out. But that's not exactly an agent. I think the agent is more like it's like a small brain. It can do some basic stuff, but it has to be like uh independent and do more things. Oh, I don't think I explained it very clearly, but there's some difference. Like
But yeah, okay, so I thank you for the explanation. I get it by you using the analogy of AlphaGo. So basically, it's more independent. It's like a small robot just for certain scenarios. Um, I haven't checked out some of the good AI agent applications yet. If you have like recommendations and like stuff for me to try out, we can definitely discuss later. We'll just assume AI agents, it's sort of AI robot. It's not a chatbot, but it's like a small brain or AI robot. Is that a good
yeah,
understanding for now? Okay. Okay.
I think chatbot can be seen as a agent, like especially ChatGPT, because if ChatGPT doesn't know something, it can search the internet. It's similar to like calling external tools,
Mhm,
or sometimes it can uh use the thinking mode, right? If the question is too hard for them.
mhm.
Uh, yeah, I think ChatGPT is a good example. Although we have been using a lot, we don't think it's an agent, but I think it's an agent.
Mm, okay. Let's
Um,
keep going
yeah,
in
yeah, yeah. Okay, okay.
the next
But we,
paragraph.
because but there are more to talk about agent. Like but we don't need to talk about like too many spend too much time on today. Like talk about agent.
Yeah, if like any of the audience is interested in, or we just being more interested in agents and stuff, we'll definitely find another reports and like papers about AI agents, and we'll read it on
Yeah,
another time. Okay.
yeah, yeah. Okay.
Yeah. Uh,
The evolution to agentic AI has been rapid and resolute. When OpenAI released the early demo of ChatGPT 3 on November 30, 2022, wow, my cat. The generative AI chatbot quickly went viral. Within 5 days, ChatGPT had introduced 1 million users to its powerful ability to create original content on demand. This marked the beginning of the Cambrian-like explosion of Gen AI applications.
and do you know what is Cambrian like?
Cambrian in I know Chinese is the Han Wu Ji. It means the era
Oh,
in the past that gives a lot of like a new life, new animal.
okay. Okay. I personally, I don't have any questions about this paragraph. It's just, I think a lot of discussion around Gen AI is started with OpenAI and ChatGPT. It's definitely like a mark, a milestone, like represents this era of AI got started. But I don't have questions about this paragraph.
Okay, then read the next one. I guess.
Okay, so multimodal Gen AI is a natural extension to Gen AI. In the real world, people encounter and comprehend information through a combination of different modalities, such as text, audio, visual, and sensing. Multimodal Gen AI replicates this process by combining and analyzing different types of data inputs to generate more robust results. A shift is now underway with the development of natively multimodal Gen AI models such as OpenAI's GPT-4o. Gartner estimates that by 2027, 40% of Gen AI solutions will be multimodal, up from 1% in 2023. Well, my input on this part is that I think this report's got a very clear vision on what's gonna happen in terms of um
Yeah.
the agentic AI industry. Definitely multimodal is going to be a big trend. And thinking about like robots in general, like the AI is going to be the brain of the robots, but at the same time, it needs all the like physical sensors, like the imagery sensors that will have like all formats of inputs and all this types of inputs. It's basically a model. If if you think like that, a multimodal Gen AI agent is going to be more and more comprehensive and maybe eventually it involves to a robots. That's what I think.
Yeah, I totally agree. Like traditional text only model is kind of like fall behind already. I think multimodal is the future. Let's think about like in the future we can wear a glasses. Like I think Google has some glasses and Meta also has some special glasses. And
Mhm.
if you wear that, it has some sensors like cameras. We have already seen the ability of like ChatGPT, right? It can talk to you real time with the camera on, right? It can see the world. It can give you real time feedback. If you go to like a grocery, like a market, you just open your camera, it can see all the like fruits, vegetables. It can maybe like give you recommendations what you're gonna buy today, and based on your like a diet, something like that.
Oh, that would be really cool. I'm like definitely being excited to see how this will progress and maybe it will eventually look like what happened in those scientific films, right? You have a watch or you have glasses that basically has like those AI um, recommendations or like it can help you to do a lot of things, but that's like in the future. Let's just see. I'll keep
Yeah,
reading.
like the movie Her or Hers, Her.
Uh-huh. Yeah, I remember that. Okay. Yeah.
Also, I have some input about this. I like last few months, I read some papers. So I think one of the future trends is that you know, currently AI are kind of passive. Like we have to ask questions and to get feedback, right? But in
Hmm.
the future, I think the AI can be proactive. It can give you information or even ask you questions proactively, not just being there passively. Like
Hmm.
especially you wanna like a AI partner, you don't want to just like the partner the to be a something just sit there for you to ask questions. If you
Yeah.
wanna if you want this thing to be alive, feel alive, it can also ask you questions.
Yeah, you just need to train the AI like in terms of how specific personalities or specific professions would would think and ask and like do stuff, right? Like, okay, that's some random idea. Keep reading.
As shown in Figure 1, Agentic AI represents the next frontier in this evolution, providing autonomous decision-making, planning, and adaptive execution to complete multi-step processes. By 2028, at least 15% of day-to-day business decisions will be made autonomously through agentic AI machine workflows for rule-based tasks, up from 0% in 2024, according to Gartner. These AI agents.
Let's see the picture real quick.
I think this is when ChatGPT 3 comes out. And
yeah. There's still ChatGPT. But like in 2024, which application he's talking about?
GPT 4.0.
Oh
4 is
yeah,
a
okay.
multimodal one.
Okay. So yeah. That's okay.
Okay, these AI agents powered by large language models and equipped with increasingly advanced reasoning abilities will be able to discover and learn individually. Then over time, AI agents will collaborate with each other by forming chains of operations, which will enable them to automate business functions. This new Internet of Agents era is defined by Cisco as an open, interoperable. I don't know this one.
Interoperable, I
Okay,
guess.
interoperable Internet for agent-to-agent and agent-human quantum-safe communication that enables secure agent collaboration while preserving organizational autonomy. Yeah, I think this part mentions a multiple agents working together. Yeah, see this yeah, AI agents will collaborate with each other for forming chains.
Yes. Yeah. Definitely, that's like what I mentioned about in the first paragraph when AI agents, they work together, like how would they transact their money? It's like using blockchains and cryptocurrency. Yeah, I think that definitely will happen because it's really, if you think of like a functionality of an enterprise, right? I work in banking. So if you register for an account in a bank, that involves multiple departments, a chain of actions and data workflows to like eventually register you into the banking system, and that can definitely like um, take parts and being done by multiple AI agents. Let's just give a random example. Do you have any?
Yeah, I think I also studied a little bit about multi-agents. I worked on, no, I didn't work on, I experimented on some traditional board games like Werewolf and Avalon powered by large language models. So each character is played by a LLM, and basically you light up several LLMs to play Avalon or Werewolf. And similar idea is, can you see this one?
Oh
The
yeah,
GitHub.
okay, I can see it.
Yeah, this is a pretty famous one. I think you shared a post about this.
Yeah.
Oh, I think they made a new website. Last time it's not like this. Woo.
Okay.
Anyway, so this is just an application of multi-agents. So each character, each NPC can be seen as like an agent or powered by LLM, so they can interact with each other.
Hmm.
You can take a look at this later.
Cool. Yeah. Okay. I'll definitely take a look.
Okay,
I'll keep
next.
reading. The agentic AI life cycle. The agentic AI life cycle builds on current AI LLM and inferencing models. The foundational elements for agentic AI architecture is the pre-training of large data sets that create general purpose foundational and frontier LLMs. These LLMs are fine-tuned based on additional domain-specific data to create domain-specific or job-specific LLMs. Um, yeah.
Oh, here.
So, can you drag
But
down? Or okay, so you finish reading this part, and we can discuss it together. Enterprises use retrieval augmented generation RAG, and other inferencing techniques that augment contextual information from proprietary databases to generate more accurate and relevant responses that extend beyond the scope of the original model. Go ahead.
Oh, okay, I'll read it. Agentic AI workflows provide the ability to make autonomous business decisions and can greatly benefit from collaboration with connected agents working across multiple devices types and locations. The powerful ability to combine the intelligence of agents with specialized knowledge to make decisions and act in real time has the potential to drive substantial business impact across every aspect of the organization. So this
Okay, so
retrieval augmented generation was a big thing last year.
yeah.
It's not that hot as last year right now, but it's a hot thing last year.
Yeah, so like couple things worth mentioning in this whole paragraph is first, it mentioned the like the pre-trained this foundational model and a frontier model, if I understand it correctly, is that we have a foundational LLM model as a base, and then we fine tune it with this like what's that called? Like domain knowledge, domain specific data, like for example in finance or like healthcare, that we fine tune it according to like this private set of data that's related to the business, and then combined together, this LLM uh, is worked specifically for this domain. Is that my understanding? Is that correct?
Yeah, like how much do you know about this whole process? Like uh do you know like
Please explain, expert,
okay,
explain.
I'll give you some of my understanding. Like let's talk about GPT-5. Or yeah, GPT-5. How was GPT-5 trained? So nowadays, pre-training is a big thing. Only those big companies can afford this. Like nowadays, models are so big, even fine-tuning is almost impossible for individuals or small companies. Only those big companies can do this. So find like this is a very important pre-training. It really determines the ability, the potential of your model. Um, like we don't talk about structures like the internal techniques like a transformer or MOE. We don't need to talk about that. We just talk about like a general overviews. Pre-training is like you collect like a big amount of data from internet, Wikipedia, the entire Wikipedia, Reddit's, like a tweets, and everything you can grab, like open sourced books, articles, everything as like a then you just use your transformer to like, but you need to make sure your model is big enough because there's a theory. So you if your model is too small, it cannot contain enough knowledge. Even your data is big. Your model has to be sufficiently large to contain those knowledge. But if your model is
Can
yeah,
you, but, so
yeah,
like,
yeah. Go.
Even though your data set is very large, if your model is not big enough, can I interpret it as if the parameters are not large enough or can I interpret as that your model is not big enough?
Let me give you an example. Let me give you an example. Let's say this article, right? This entire article. If I only use a very small model, let's say like 100 parameters, it's impossible for it to even memorize all this information. It can only memorize maybe this one paragraph for 100 parameters. That's what I meant. So think about this article is the entire internet of data you collected. So you need at least like some very large models to at least memorize all those informations. So
Okay.
yeah, do you have a better understanding now?
So it's like a LLM models will have like billions of parameters. First they need to memorize all the contents from the internet, and then they need to like they also need some other parameters to fine tune or whatever to study.
No, don't talk about fine tune. Fine tune is like it's not that well, it's important, but it's not the big like the main part. Main part is the pre-training. We need to understand what is pre-training. What does it do actually? There's like a
explain.
yeah. So I want to point out that like why is nowadays model so big? It's because our data is so big. And based on the information theory, for every word or every bit of information, you need something to store it. Essentially, LLMs or like language models are just like a compression of the entire internet data. It's like you do the zip, you know the zip. Originally your data is like 10 megabits. You zip it, then it reduces to like 5 megabits. This is similar thing. You train your model and you try to let your model memorize this whole thing, all your data, and but you don't want it actually memorize everything. You want it to basically like compress it. If you compress it, it can create some sense of abstraction, like latent variables. If you can do that, it has suddenly, like surprisingly, it can have some like a reasoning ability. It's like people haven't figured out why, but it's kind of interesting. If your model is, you don't want to make your model so big. If your model is so big, it will memorize everything. That's not what we want. It's like overfitting. We don't want it to overfit, but we don't want it too weak. We want to find a balance.
So it's like compress the entire internet into a huge matrix. It's is that like a proper analogy?
Yeah, like do you know this auto it's called a auto regressor? The auto regressor. Like encoder, decoder. I think you learned this in machine learning.
Oh my God. Oh my God. I'll read it. I'll watch videos on this one. Oh my God. Or maybe
Look at this.
okay.
Why is it so blurry? Yeah. This is what I'm talking about. Really important, really interesting. So this is a input data, and this is the latent space. This is what we want to get, and this is we try to reconstruct.
Okay.
So think about this as our like entire article, and we're trying to use a small brain to kind of memorize it, but not entirely memorize it. And then we try to let it to speak out what it has remembered.
Okay.
Similar to our brain, like you read this whole article, right? You you don't want to literally memorize every word, but in the end, you can, if people ask you what have you learned, you can tell other people what they have read, right?
Yeah. You have a understanding or like interpretation of the articles, and you memorize some part of it. Okay. Yeah, I get it. I get your analogy. I'll read stuff related to this probably next time. Um, okay, so keep going with this figure two.
Yeah. So we have pre-training. This is very costly. But once we have the pre-training, okay, I have to talk about what are we actually doing. What is X and what is input and what is output. So before we're talking about training, we need to know what is the input and what is output. So basically, the input is a, like, for example, this could be like an input. This part of the sentence, your output is, your objective is to predict the rest of the sentence. So this could be your like output. So given the input, predict the output. So after the pre-training, it can do a very good job like recalling or remembering the original text. For example, after like training this whole article, if you ask, if you put this like into the chatbot, this not chatbot, like give this sentence, the part of the sentence to the model, it will literally give you the rest of the sentence, almost perfectly. I think if the training is very good, but that's not what we want. What we want, because in order for the model to behave the way you want it to behave, like let's talk about ChatGPT. It used a technique called reinforcement learning with human feedback. So because your training data doesn't consist of dialogues that much, it doesn't, because your data are mainly like internet data. It doesn't have a lot of dialogues. So you want guide or tweak the model to perform more like a assistant. So you have to feed it more like dialogue data. Like for example, ask what is the weather today? Who is the president of the United States? This kind of questions. And basically you guide the model. That's where the fine tuning comes in. You tweak the model's behavior because you want to make it behave the way you want it to behave.
So like if we don't fine tune the model, if that means it's more like it will behave more like Wikipedia.
Yeah, it's more like what I described here. You give it a sentence, whatever sentence, it will try hard to remember what the rest of the sentence is. And if it sees a like a very unfamiliar sentence, it will give you some nonsense, I think.
Oh, okay. So it's like the natural behavior of the model is more like a sentence continuation.
Yes,
Okay,
correct.
okay. So you like basically OpenAI fine tune it into a chatbot, into like a language based like conversational
Yes.
response. Okay, makes sense.
I give you one more example. So, like I said, I asked you a question, what is the president of the United States? Like, for example, if this question did not occur in our training data, the model wouldn't know how to answer it. Although it has this kind of knowledge in its brain, in its like attention or matrix, but it haven't seen this kind of question in their input. So it doesn't really know how to respond to that, although it has knowledge about it.
Okay. Okay. Yeah. Yeah. Like, well, I'm now interested in how like OpenAI did this fine tuning part, but we can save that discussion later. Let's keep on going. So you
Yeah.
explained this picture. Can you explain the like the next part, the part
Yes. Yeah.
on the
Sure.
right?
So once we have this finished model, like the ChatGPT 5 or like Claude, anything. Then we comes to the inference part. So once the model is trained, we only care about inference. Inference means like you basically ask questions, it will give you feedback. So, well, for big companies, they have their own like data center to serve their models. But for if we wanna like serve our own model, we need to have our own GPUs. For example, we wanna serve DeepSeek, we have to download its weights from like the internet, and then we serve it with our own GPU. Then we can do local inference because sometimes we have some like private data. We don't wanna, if we use a ChatGPT service, we're probably gonna send our private information to their server. It's kind of dangerous. Anyway, so now we have some AI agents. Yeah, this is a RAG. This is related to the also related to the private data because, for example, you work in finance. There are some documents you cannot share. So think about it as a vector space. Are you familiar with? Do you want me to explain what this is?
Yeah, yes, please. Let me summarize what you're mentioning earlier. So, the model serving and the inferencing part is more related to how we're gonna um deploy the pre-trained model into our local content. For big companies, they have data centers. For like individuals, we have like our own servers and like our local GPUs. Um, so this entire layout, it's what this article is trying to discuss about, and also this RAG, RAG is okay. Keep explaining on this RAG.
Yeah, yeah. So basically, this is a training part. Once the training is done, if you want to use models, it's basically called inferencing. As long
Mhm.
as you give the input to the model, it will give you output. That's inferencing.
Yeah.
You can serve the model by yourself, or you can use OpenAI service. They all call it inferencing. And usually, inferencing is much cheaper because updating with training is more like a costly. Anyway, so let's talk about RAG. For example, like let's say this whole article is private. It contains some of your company's private information. You don't want to use ChatGPT service. So what you can do is like you cut this whole article into pieces. For example, you cut it here, make this X1, and cut this part X2, and cut this part X3, basically, and go on. Then you
Or
create, yeah.
uh-huh. Or like we can use a more realistic example, like in terms of banking, we store the account informations and the informations about the customers in our local database. So there's no way that we can share all this information in on the internet. We have to um like this has to be in a vector where we're using RAG to retrieve the information from our local
Yeah, yeah, you're
PC.
right. Basically, it's all about context window. Usually the context window, or Google's Gemini has like 1 million context window. Sometimes that's not enough for us. Mm, the ideal way is to like put everything into our chat, like the chat box, then let the AI to figure out like where the information is. But
Mm-hmm.
since we have limited context window, we have to ask for some turn to other tools for help. For example, vector space. Basically, what it does is to cut the entire articles or your database information into smaller chunks text data, and then we convert each chunk or each text, each sentence into a vector. And then if we have some questions about your database, for example, I want to ask, like, what is your prediction on 2028? We want to figure out, is this number right, 15%? But we, based on our query, we ask this question, and then we compare this query vector against your entire vector space. Then we find the most similar ones. Hopefully we can retrieve like this part of information, and then we feed this part of information to the AI, like chatbot, as a context, more like a prompt, similar to prompts. And then if AI has this part of information, it's a really easy job for the AI to figure out this number, right? Because yeah,
I get it. Yeah, I get it.
yeah,
So
I think
like
that's
the limit.
yeah, that's the whole thing about RAG, I think.
Yeah, so like the part of the issue is the limitation of how much information you can put inside the chatbot because
Yes.
it's very expensive. So what you want to do is like store all your information into a vector space and then just put the particular. So when you trying to retrieve that piece of information, you basically need to find that specific vector and put the small part into that chatbot so that you can save a lot of money and also get the correct result.
Yeah. Also, do you know why? Like, even though, let's say you have a very big context window, but even though that's the case, the AI doesn't perform very well if the context window is too large. If you insert like a bunch of data into the chat box, it will probably forget the most important information. There's a thing called a needle in haystack. People do some experiments. Uh, have you seen this kind of thing before?
No.
Okay, now I'll briefly talk about it. So basically, the y-axis here is the percentage of depth. So basically, it means you give this a model a very long text, but you hid some you hid some information based on the depth. So the 0% depth means like you put your most important your like treasure on the first sentence, for example. And if it's a 50%, you basically hide your treasure in the middle of your long text. And then this see this x-axis means the context length. This is a 1,000 and this is a 128,000. And this red, I think red color means fail. Green means successful. So based on this column, the first column, it means if I give this model like a 1,000 tokens, and if no matter, it doesn't matter where I hid my information, it can successfully give back this information. Do you
Okay.
understand?
Yeah, I get it. Yes.
Yeah, but the things will become more difficult if the contact lens becomes larger. I'm not sure this photo is that perfect, but let's see this one. At least it failed a couple of times here. So usually the shorter the context, the better the LLM performs. That's the conclusion.
So yeah, so it's basically like if you put too much information in the chatbot, you kind of like dilute or pollute your pureness of your data, related
Yeah,
data.
yeah. Look at this thing. It performs really well. For this model, like if you use like tokens less than 10,000, but once it's beyond 10,000 tokens, so bad, becomes so bad.
Okay. Okay, get it. Yes. That
This is
makes sense.
yeah, this is very important to think about.
Okay, that makes sense. It's kind of like if you put a bag of sugar into your like grande coffee, you will still taste the sweetness. But like once
Yeah,
you have like two venti cups of coffee, you put one bag of sugar, you like you won't find it basically.
yes, yes.
Okay, keep going. Keep going.
Uh, yeah, we understand why we use this technique, and there are two reasons. One is private data. The other reason is the limited context and the ability, the AI's ability degenerates when the
Mhm,
context window is too large. Yeah,
mhm,
three reasons, I think. And then we have the prompt engineering. Yeah, this is a technique to basically how to guide your LLM. You write some like instructions to tweak or control the behavior of your LLM.
mhm.
This sounds like something scary, but it's actually pretty basic. You just write some commands. For example, be a nice friend to me, only speak nice things, or like be a teacher to me, something like that, you know.
Yeah, yeah, it's how you treat your ChatGPT. You can like basically train your ChatGPT into your like to give them personalities or like make them more professional on specific domains based on these prompts. A lot of like well, like for me, I don't I just copy and paste some specific prompts
Yes,
that from Reddit that people provide for maybe like um like make your resume better or like in terms of coding there are a lot of prompts that on there over the internet. Okay, so next part.
and one more thing, this is actually important because, for example, you utilize AI. For example, you are building some agents. You give the you ask some questions to the agent. You only want the agent to return you certain format. For example, you are asking this model to do math questions. You only want this model to give you a single answer or single number. You don't want this model to give you like a bunch of explanations because sometimes you
Mm.
need it. That's where the prompt engineering comes in.
Mm,
You can give the LM instruction like only return me a number. Don't say anything else. That's an example about prompt engineering.
mhm.
And
Well,
this,
I have
yeah,
a question. So
yeah.
like what do you think about those like classes or like courses on the internet teach you how to be a prompt engineer?
Yeah, I think I've seen those kind of videos, like articles. It's useful. Some people do hire prompt engineer. Um,
Okay.
but I think it's not that popular right now. There's a new thing. What's the new thing? I think I've seen this prompt engineering versus yeah. There's a called context engineering.
Uh-huh.
I haven't read this yet. I haven't. Yeah, I don't know. But I think it's kind of similar. Maybe we can read this next time.
Okay.
Anyway,
Yes. Yes. Anyways, and then the last part,
uh,
super.
a rule-based is a old term. Before we
Mm,
have LLM, we you kind of use rule-based. Like it's like a think about chess bot. Uh, Before we have AI like AlphaGo, we only
mm,
have rule-based like AI. Rule-based is like a human written rules written by human.
uh,
But that's the bad. One of the shortcuts is that we cannot foresee every scenarios, every input. That's the drawbacks of like a rule-based.
Mm-hmm.
Yeah, for example, the chess, we cannot have seen every scenario. So in some scenarios, we might fail. The system might broke, or it just don't know how to respond. But I think the term rule-based agent here is kind of like a mixed thing. It's a mixture of agents and rule-based. Because think about like a customer service chatbot. Sometimes you can use rule-based, right? And then sometimes you wanna bring the LM to the playground.
Yes. Yeah, definitely. So there's some rules in the business context, whether um like this specific problem is out of leash or this we should transfer to the next
Yeah.
department if you think about customer service. That's definitely there are a set of rules that can be applied, but it's like you said, it's not a chess game, it's not a Go game, it's an open system where like
Yes.
some part is not entirely can be closed by those rules. Yeah, I can get that. Sure. Well, so basically, let's just finish right there because it's over an hour right now, and
Yeah. Let's wrap it up.
yeah, let's just wrap it up of like what this part of the article is talking about, and what we have discussed today. So we um read about the agentic AI, like how it will evolve in terms of in the next 5 years or next 10 years. That's a prospect made by Cisco, and we basically discussed about the um, Agentic AI life cycle. That's their name, but we kind of discussed about the structure and the underlying layers of a front end from the foundational models to the front end AI agents, like what's going on, what happened in between in the whole process. And I think Jilin did a really great job of giving his insights on a lot of stuff. Because I, like as I said, um, I've after I graduate from Berkeley, I haven't touched anything about like machine learning and AI stuff for a while, and a lot of knowledge. It's an eye opener and definitely very, very useful. Um, I learned a lot in today's discussion. Thank you, Jimmy.
Okay, no problem. I
Thank
think
you, 大佬.
I think like don't think machine learning to be a very difficult thing because it's like software engineering. Abstraction is very important. I think human needs abstraction. Like you need to make things easier for people to understand. Like don't think about too much about the details. Like if you really want to become a like a AI engineer, you probably need to get into the details. But those things are really boring. It's like those they pay attention to small details. Like if this structure change can boost 1% performance, I don't think they're really interesting. But I think it's more important to understand the basic structure and like the how things really work, like why things
Yeah,
work.
the overall the overall picture, the higher architect of this whole thing is definitely very important to know with anybody who wants to like find their career in this industry and or just don't want to be left out. It's still like just to understand the architecture and understand the like the overall how this whole thing works, it takes up a lot of works and understanding, a lot of research. So this series, this read with us, read together, whatever series is kind of like a way to ease into all that domain knowledge about AI and this industry. I hope we can continue to make those videos and like keep posted on the internet. I understand it's very long and probably nobody, so, probably nobody, but well, some people, if they get bored enough, they will like listen to our discussion, but only in the process, like even if just during the process of making the videos and have this discussion made me learn a lot more and have a lot more insights on these knowledge that I have to learn, and it's such a better way of learning. And thank you so much. Oh
Okay,
my
you're
God.
welcome. You're welcome. You're welcome.
Okay, so let's say goodbye. And at the last, I don't know what people are gonna watch this, but I'm currently looking for a job in like AI infrastructure startup as a business development representative or account executives, and Jilin is looking for a job in machine learning engineering, right? Right? Like
Okay,
we're
let's
open for like opportunities to collaborate and open for like opportunities, open for job opportunities, please. So okay, let's wrap this up. Do you have anything to mention? If not,
I think this is just the beginning. Like I think we'll get more used to this kind of thing if we do more like reading together in the future.
okay, okay, cool, thanks, thanks everyone. Let's cut it off today. Thanks.
Okay, bye.